Okay, so this is another problem on a block on a horizontal plane being pulled by an inclined force P. We need to find the minimum force P required to cause the motion towards right side. That is the impending motion towards the right side. So of course, because the motion is not started yet, this is a problem of statics and we should consider accordingly. Let's draw the free body diagram. We can see the force P is acting at 14 degrees, which is given in the question. The mu value given in the question is 4.3 and the weight that is acting downwards in the question for us, it has been given as 122 newtons. To act against that action, the weight will have a normal reaction N, and because the motion is impending towards right side, friction force will act towards left, trying to avoid that impending motion. So that friction will be 0.3 times normal reaction, and that completes the free body diagram. Let's take the sum of vertical components first. N acting upwards, 122 newtons acting downwards, and there is another force, the component of P, that is acting upwards, and that component is P sine 14 degrees. So this total has to be equal to 0 because it's a problem of statics. N is not known, 122 is substituted, P is also not known, 14. Let's take the constant to the other side and we get 122 equals N plus P sine 14. This we'll call it as equation 1. Next, we'll have to take the sum of horizontal components from the same free body diagram. So P cos of the angle 14 degrees, that is acting right side, hence positive. 0.3 N is acting on the left side, hence it's negative. The sum of all the horizontal components has to be 0 because it's a problem of statics. Let's put it in the correct standard format. N needs to come first, so 0.3 and P goes here, so that is P cos 14. Let's call this as equation number 2. Now let's solve the equations using our calculator. We are already in the equation format, which you can go for mode and choose an equation containing x and y. So this at the top you can see this is the standard format, ax plus by plus equal to cn, and accordingly we'll have to take the coefficients. So in place of x in our calculator, let us assume n, and in place of y in our calculator, let us assume p. So let us feed in the coefficients. In the first equation, coefficient of n is 1, so let's put 1 equals, and coefficient of p is sine 14, substitute sine 14, press equal, and the constant is 122, feed it, press equal to. In the second equation, coefficient of n is minus 0.3, press equal to. Coefficient of p is cos 14, so press cos 14 and press equal to, and the constant is 0 itself. So once again press equal to get the values of x and y. So x in the calculator is n for us, so let's write 113.51, and once again press equal to get y value, and y value in our calculator is p for us, and that value we're getting 35.10 when you round it off. So these are the values. Let's go back to our question, and here he is asking the minimum force P, that is this value. Let us substitute here 35.10 and submit it. You can see our answer is matching exactly, and that's how you need to solve. Of course, the values of W, mu, alpha will be differently created for each student, so you'll have to take those values, apply the same procedure and solve it. Thank you.